Hello, people. All right, so this is the third video for Chapter 12, which is Forces of Evolutionary Change. And if you are wondering what is due this week, consult your syllabus schedule. And also, I post it underneath all of the YouTube videos in the video description. If you have any questions, go ahead and post a comment under the video, and I'm going to share my screen so that we can get started. So last time we were talking about artificial selection. Oh, come on. Artificial selection, natural selection. We talked a lot about evolutionary thought and how it has changed over the millennia. And today we're going to talk a lot about the real forces of so natural selection, artificial selection, those are forces of evolutionary change. So are sexual selection. And then we're going to talk about things like migration, genetic drift, mutation, and things like that in this last part of the video. So, guys, sexual selection, it will directly influence reproductive success. So in sexual selection, you have certain individuals in a population who are selecting mates, okay? And a lot of times when you have one sex selecting mates, that drives this really sort of ornate behaviors or like showy plumage or like violence between members of the opposite sex. Okay, so here we have this gorgeous nest building behavior. You have like really ornate, you have this beautiful plumage, which okay, both of these are going to make them more obvious to predators. So we'll talk about why this is advantageous. And then also you have like violence, you have competition. So how can natural selection allow for traits that apparently reduce survival? All of these traits would reduce survival, but it also increases the chance that these individuals will be able to reproduce. And that's what natural selection is all about anyway. So sexual selection, it's a type of natural selection resulting from variation in the ability to obtain mates. There's a lot of different ways that this can happen. Well, a lot of different ways that this shows up, but there are two different sort of modes of sexual selection. The first is either from competition for access to the other sex, like these rams. So for instance, if there are, say that you have a population of rams and their habitat is really spread out so that when you come across a female, it's rare. It's not all that common. And then if you have a female and you have multiple males, they will duke it out in order to be able to win the rights to that female. So the competition for access to the other sex, this is a case where it could be like really open territories where coming upon a female is rare, or it could be where this happens a lot in fish, where you have a ton of one sex and very little of the other sex, okay? The other way that sexual selection can happen is from one sex, typically females, choosing attractive mates of the other sex. And that's where this nest building behavior comes from, or the showy plumage comes from, even though it would reduce the fitness of the males who are building these intricate nests or have this showy plumage. It's a show of health, okay? So again, here is sort of a review of these two forms of sexual selection for you. The first, members of one sex, typically males, compete with each other. And this is where the winner, usually males, will win access to the females. Winning fights is synonymous with you have good, strong genes, because if you are frail, you will not win access to that female. You will not sort of, your genes will not be passed down to the next generation because you will not reproduce. So why is this typically males? If you can think about this, sorry, I'm in the most uncomfortable chair you've ever even seen in your life. So why is this typically males? Why are males typically competing with each other for females? Well, would it be beneficial for the species for females to compete for access to males? No. Females are the future of the species because only females are actually able to birth the next generation. So it's usually going to be males that are competing with each other to win access to females. The second form of sexual selection, members of one sex, typically females, choose from many individuals of the opposite sex, usually males. This is where you create elaborate displays, bright colors, like really long plumage. If you think about like peacocks, is that advantageous in the wild? No, you have all of this plumage for a predator to like grab onto and like rip them away. Okay, so not great, costly to produce and maintain, but they indirectly signal good health and disease resistance to the females who are looking at them. So if you have a male with like really dull plumage, or like it's not well kept, like it's just like all over the place, well, it indirectly signals bad health if they have this dull plumage or it's not well kept. Okay. All right. Generations of choosy females have selected for males with nest building traits or elaborate ornamentation. And though this is going to make them, like I said, more vulnerable to predators, it's also a mating opportunity. Every mating season when they do this, it is a mating opportunity for them. It's an opportunity for their genes to be passed down to the next generation. So we are going to watch this video, and I'm going to, hold on. I'm going to share my screen. I have so many tabs open. All right, I'm going to share my screen so that we can watch this video. This is so cute.
So that is how it should be done.
You didn't show this to me. Stop it. Just said internet connection is unstable.
Junior returns to his own bower and tries to improve things. That should probably go just here. Or maybe here. Perhaps he was right in the first place. He just can't make up his mind. This could take some time. And it's not just about building. The master's bower has something that Junior's lacks completely. Blue decorations really please a female.
Okay, most of that is trash. So once again, humans affecting
Junior takes
the evolution of animals.
Look. What will the master make of his visitor? Rather than drive him away, the master has other intentions. Seduction. Juvenile males are almost identical to females. So the master grabs the opportunity to practice his courtship display on him. Junior doesn't know what to do next. So he exits mid-performance. The youngster's power. With the breeding season close, adult males grow increasingly intolerant of juveniles. Oh dear, there's virtually nothing left.
Bubba.
Junior will just have to start all over again.
Okay, bowerbirds are amazing, and that is just another example of sexual selection where you have birds, birds gathering. Hold on, I'm sharing my screen again. Birds gathering all sorts of colorful things in order to attract mates, building these beautiful bowers, which are these sort of nests on the ground, and yeah, okay, doing these elaborate dances just to attract the females. So here's a question for you that would have been a clicker question. Humans selecting for dogs with keen senses of smell is an example of which of the following? Is it sexual selection, artificial selection, or natural selection? Well, if you're selecting for something, it's not natural selection. And if it's humans with dogs and not a male or a female dog, then it's not sexual selection, so it's artificial selection. All right, so evolution doesn't just occur with natural selection, artificial selection, or sexual selection. Also, there are lots of other ways that you can change allele frequencies over time via mutation, genetic drift, and migration. We're going to talk about each of these in their own, like in order, but I encourage you to use this slide to sort of begin to understand what's happening in each of these. Okay, so come back through this PowerPoint. Genetic drift, this is a major player. Okay, occurs only by chance. Most common in small populations, and examples of genetic drift are going to be founder effects and population bottlenecks. So just remember, genetic drift purely by chance, and examples are founder effects and population bottlenecks. But the reason why genetic drift and how it's just by chance is going to affect smaller populations much more intensely than larger populations. If you have a smaller population, you already have less genetic variation in it. Okay, if you have less genetic variation, then what that means is that if a typhoon comes out and wipes away half of your population, now all of a sudden you have even fewer alleles in your population. Okay, so it's basically knocking out genetic diversity with genetic drift. So this is the founder effect. When only a few individuals establish a new population, the allele frequency might change. This is the process that illustrates the founder effect. So if you have, for instance, genetic diversity, this is the genetic diversity in the original population. All of these colors, a small subset are going to move over to a new habitat, whether that's an island, whether that's a new colony, whether it's whatever. They're going to start their own community. And as you can see, there are only 3 colors in here, okay? 3 colors for 3 different alleles in here, and much less genetic variation than in the original population. Well, what that means is that the small group's allele sample might not represent the allele frequency of the original population. And now traits that were present in this small subset of the original population that went and formed their own new colony are going to be like way amplified. So for instance, you have an Amish population, an Amish colony in Lancaster, Pennsylvania, and where in the original population, this trait where basically polydactyly, more than 5 fingers. You have this trait that causes babies to develop 6 fingers instead of 5. Now that trait was not common in the original population, but because somebody with that trait in this small subset of the original population went out and formed this new colony, now it is super prevalent in that new colony over here, okay? So some traits that were rare are now much more common, and that's the founder effect, okay? That subset of genetic variation you have brought to a new place, and it has just exploded only with that, okay? All right, another type of genetic drift is the population bottleneck. And this is like the example with the typhoon, okay? A population bottleneck occurs if a disaster drastically reduces the size of a population. This could also be hunting. This could also, like, whatever it is, okay? Something occurs and you take a population that maybe already didn't have very much genetic variation. You take out a pretty big subset of individuals, and all of a sudden now you have even less genetic variation. So you lose many of the alleles that were present in the ancestral population. Even if repopulation occurs, you still have a permanent loss of genetic diversity. The perfect example of this is with cheetahs. Cheetahs have so little genetic diversity in the wild, and it's like no better in zoos. Okay, so just the fact that there are so few cheetahs just roaming around and able to reproduce with each other. Also, they're really shy, which is really cute, and they don't actually like to reproduce. But that's a whole different thing. If repopulation occurs, if all of a sudden all the cheetahs were like, hey, we're ready to do this, we are ready to repopulate the earth with some cheetahs, you would still have only that small subset of alleles, permanent loss of genetic diversity. That was your last example with genetic drift. Remember, completely random, loss of genetic diversity affects small populations even more than large populations. Now, migration is another way that evolution can sort of occur. So migration moves alleles between populations, and this might affect the allele frequencies in both populations. And our example from part 1 of chapter 12 was if a Swedish person leaves Sweden and moves to Korea, where she meets the love of her life, they interbreed, she is living in Korea now. Not only has the gene pool in Sweden lost her alleles, but now because she has interbred with somebody in Korea, you have this sort of, you're adding her genes to the gene pool in Korea. So you're removing them. In this case, you've got different colors of bunnies, okay? You're removing this rabbit's genes from this gene pool, adding them to this gene pool, okay? So you have this change in genetic diversity between populations with migration. Okay, wait, did we? Where's, okay, wait, okay, we didn't even go over mutation. All right, so basically, guys, I'm just gonna, this is for you. This is from your textbook. We don't have a slide on mutation. That is okay. This is basically, you can have lots of different types of mutations, okay? You can have insertion mutations, deletion mutations. You can have substitution mutations where one nucleotide becomes another nucleotide. And they occur for lots of different reasons. They can occur because from UV radiation. They can occur from lots and lots of things. A lot of times it's random, okay? Random mutations where one genotype becomes another genotype, and that is going to increase genetic variation in a population. So in this case, your starting allele frequency, you had 3 different alleles, and in your resulting after the mutation, your allele frequencies, you have 4 different alleles, okay? even if this yellow allele, this new yellow allele is only present in a very small portion of the population, doesn't matter, because all of a sudden that could have been antibiotic resistance in bacteria. And all of a sudden, because this is finally showed up and you have antibiotic resistance as a selective pressure on a population, now that allele is going to explode in the population. So this is how change occurs. This is how new traits arise in a population. All right. Here are some evolution videos. I particularly recommend this one. It's about 10 minutes long. Funny, great, awesome. Will probably pull a question from it for a quiz or something. So I encourage you to watch that. And guys, that is it for chapter 12. So y'all just have a great old day. Bye.